Hello, my name is David Adams. This is a presentation for my Capstone project report, Preparing for Wildfires, a Fire Risk Analysis of Potential Archaeological Sites in Riverside and San Bernardino counties, California. This was done for my employer, Statistical Research Incorporated, where I work as a GIS technician. Now, I say potential archaeological sites because archaeological site data is protected by the state out of fear that people know where archaeological sites are. They might destroy them or otherwise steal artifacts from them. So, in order to perform these analyses, we came up with an analog that we can use as a stand in for archaeological sites, and that is natural springs. The reason we chose natural springs is because natural water sources are places where you're naturally going to find people living in close proximity to, and so they act as a good stand in for archaeological site data. Now, to perform this analysis, I actually did two different analyses. The first was a traditional weighted overlay using thematic layers. And the second was a more novel approach I took using historical fire perimeter data. The logic behind that being that as a fire occurs in an area, they're more likely to reoccur due to the favorable conditions that exist in that area. So, for the first portion, the weighted overlay, basically created a composite of all the included layers using a system of weights and ranks. A thematic layer was created for each of the 8 factors that were determined to most contribute to wildfire risk in the area. For this area, that included slope, aspect, elevation, land cover, distance from highways, distance from power transmission lines, distance from springs, and NDVI. Each of these layers was classified and then grouped and ranked according to the fire risk factors present. Then each layer was assigned a weight based on how heavily it contributes to the overall risk of wildfires. Factors that were considered included risk of wildfire ignition, uh, basically the speed of spread, the ease of spread, hindrance to containment and firefighting efforts, and wildfire sensitivity. The composite map in the center distinguishes between 5 classes of fire risk. These are identified by color and range from very low to very high risk. Large portions of the map are identified as high risk, but very high risk areas are very small and tend to be clustered in forested and high elevation regions, like in the mountains along the San Bernardino mountain range, San Jacinto Mountains, and Santa Rosa, as well as a little bit in San Gabriel. For the second analysis, again, I used historical fire perimeters for this because fires often occur in the same locations due to favorable fire conditions. This analysis aggregates historic fire perimeter data from 1920 to 2020 within 100 square kilometer hexagonal cells to determine the total number of incidents that have occurred there. The other analysis uses rasters, so it's continuous based data. This is vector data, and so we're using discrete measurements, and so that's why we use these cells to aggregate the data. We can spatially join the springs point data to these cells to see which springs are at higher risk. To start off, I used the generate tessellation tool to create a hexagonal grid. You can see that down in the lower port map there. And then I imported the fire perimeter data up in the top right into the project. And I used the union tool to take the hex layer and kind of use it as like a cookie cutter and punch out the fire perimeters that they fell over top of. And so then I could do a spatial join with the hex cells and see which fire perimeters fall within which cells. Because we've punched them out, one fire perimeter can occupy multiple cells. Then we can use the sum to count up all the number of fire occurrences that have occurred within that cell in the last 100 years. And then you can see that's the map down in the lower right hand side. And then finally, we can do another spatial join with the springs layer to those cells to see which springs fall within the cells with the highest count of fire occurrences. That's the main map right there off to the center left. And again, we can see a really similar pattern as the other analysis. A lot of high risk and very high risk extreme risk sites fall within the mountain ranges, San Bernardino Mountains, some in San Jacinto. But interestingly enough, with this analysis, you can actually see there are some at very high risk around Riverside, just to the east, and some down south near Paris of high risk. Those don't pop up in the other analysis because the factors that were included tended to be of higher elevation, more wooded areas. But we can see using this sort of analysis that there have been a large quantity of fires that have occurred over the last 100 years. Now, this sort of data, when used for fire probability, is often used in conjunction with other factors. And there's a reason for this because, around Paris has been a large number of developments in the last few years where they built warehouses and a lot of construction. So some of those areas might be cleared now. There might be developed land, and you're probably not going to see wildfires occurring there anymore because those conditions have been removed. So if I were to continue with this analysis for them further on in the future, probably combine some of these elements together and not have two separate, but maybe combine some of them together to see what might work out better in the future. But overall, I think it produced some interesting results. If you have any questions or concerns, feel free to reach out with me. I'd be happy to help. And I do appreciate you taking the time here. It's been quite a pleasure.